Alright, so now I'm about to go over how to solve circuits using Kirchoff's rules. And remember, he has two rules, his junction rule and his loop rule. So I'm going to go over circuits that have 3 loops, and then I'm going to go over circuits that have 2 loops. So the first one I'm going to talk about is the 3-loop one. And one very distinct thing about a 3-loop circuit is that current 1 flows all throughout this loop, current 2 flows all throughout this loop, and then current 3 flows all throughout this loop. So the currents don't break apart. So that makes this a very unique circuit. So the first thing that we want to do when we look at a 3-loop circuit is to look at the loops that are already drawn on there, and it tells you the direction of the current. So since this loop is going this way, I know that I1 flows in the same direction. Likewise, I can draw the directions for all the loops. And then I have this final loop. Now, there are some things that you should know before doing a Kirchhoff's problem. The first thing that you should know is that when the loop goes from a negative end of the battery to a positive end, it's going to be a positive voltage. Likewise, when you go from a positive end of the battery to a negative end of the battery, it's going to be a negative voltage. So you're going to subtract it. And also, when we have a resistor, if the current's flowing in the same direction as the loop, then it's going to be minus IR. So same direction means minus IR, and then sorry, I'm trying to draw a resistor. If it flows in the opposite direction, it's going to be a plus IR. So opposite direction is plus IR. And it'll all make sense in a minute when I start this example. So I already drew my current flows based on the loops. And what I have to do is analyze each loop at a time. So I'm going to analyze loop 1, then I'm going to analyze loop 2, and then I'm going to analyze loop 3. And one very key feature is for each of the loops, I'm going to have one equation. So I'm going to have 1 equation, 2 equation, 3 equation. So 3 equations in total. And the whole goal of this is to solve for I1, I2, and I3. So 3 equations, 3 unknowns. I can solve this system of equations. And last thing I want to mention is that we have numbers underneath the voltage values. And all those numbers tell you that it's a resistor right next to the battery. And we call them internal resistances. So I can go ahead and draw those resistors in. And it doesn't matter which side of the battery I draw it on, as long as I draw it next to the battery. So I'm going to start with loop 1. And that's going to correspond to A, B, E, D. So the first thing I'm going to start with is this resistor. Now if I look at this resistor, this current arrow is going up. And then if I look at the loop, it's also going up because it's going to flow like that. So since the current's going up and the loop's also going up, it's going to be a minus 0.25. And the current I'm working with is I1. Then looking at the 9-volt battery, I'm just looking at the loop for the batteries. So the loop is going from the negative part to the positive part. So it's going to be plus 9. And then I'm going to the 6 ohm resistor. The current's flowing to the right. Likewise, the loop is going to the right. So they're going in the same direction. So since they're in the same direction, I'm going to be minus 6 I1. Now I'm going to this 4 ohm resistor, but pay very close attention because this one's special because this one gets current from loop 1 and it gets current from loop 2. So I'm going to have two different currents for this 4 ohm resistor. So if I look at loop 1 first, the arrow's going down. And if I look at the loop's also going down. So it's going to be minus 4 I1. But it also gets current from 2. And if I look, this arrow's going down, but if I look at loop 2, that loop's going up. So this arrow's going down and the loop's going up. So it's opposite direction. So it's going to be plus 4 I2. And then I have this 15-volt battery. So if I look at that 15-volt battery, it's going, the loop is going from the negative part to the positive part because it's flowing like this. So it's going to be plus 15. And then I have this 0.3 ohm resistor. This 0.3 ohm resistor, so the arrow for the first loop is going down. And then this loop is also going down. So it's going to be minus 0.3 I1. But note, this resistor, this 0.3 resistor, is also getting current from the second loop. So it's good. So since this arrow is going down and loop 2 is going up, it's going to be plus 0.3 I2. And then I go to that 5 ohm resistor, and that 5 ohm resistor is getting current from loop 1 and loop 3. So for loop 1, the current's going to the left and the loop is also going to the left. So since they're going in the same direction, it's going to be minus 5 I1, and it's getting current from loop 3 too. But the arrow for loop 1 is going to the left, and the loop for 3 is going to the right, as you can see. So since this is going to the left and the loop is going to the right, they're opposite, so it's going to be plus 5 I3. We're almost done. This equation looks pretty long, but this circuit has a lot of things in it. Then we're going to that 6-volt battery, and we're flowing from the big line to the little line, so it's going to be positive to minus, negative, so it's going to be minus 6. And then looking at this resistor right here, it's getting two currents. It's getting current from loop 3 and from loop 1. So if I do that, for loop 1, this arrow is going in the same direction as the loop, because the arrow is going to the left and the loop is going to the left as well. Because if we look at it, it's going like this. So it's going to be minus, and that's a 0.1 resistor, minus 0.1 I1. And then looking at the current for the third loop, so this arrow is going to the left, and then the third loop is going to the right. So it's going to be plus 0.1 I3. And that's all going to be equal to 0. So if I look at this very long equation, if I add up all my I1s, what I'm going to get is, okay, let's see if I can do this. Negative 0.25 minus 6 minus 4 minus 0.3 minus 5, and then minus 0.1. I get negative 15.65. So luckily down here I already gave you a nice little template. So for the first loop, it's going to be minus 15.65 for I1. Now for I2, it's going to be 4 plus 0.3. So it's going to be plus 4.3. And then for I3, it was that 5 and 0.1. So it's going to be plus 5.1. Now remember, it's all equal to 0 because for the loop rule, it says the voltages are equal to 0. So for all my constant batteries, I'm going to move those to the other side. So I have, let's see where my batteries are. I have 9 plus 15 minus 6, which gives me 18. But I'm going to move that positive 18 to the other side, so it's going to be minus 18. So my first equation should be minus 15.65 I1 plus 4.3 I2 plus 5.1 I3 is equal to negative 18. Now, I have to work on loop 2. Good job persevering through that first loop. Now for the second loop, I'm going to go through this one a little quicker. So I'm going to start with this 0.3 ohm resistor. So this arrow is going in the same direction as the loop. So it's going to be minus 0.3, and I'm talking about I2. But remember, that resistor also gets current from 1. And current from 1 is going, the loop from 1 is going down, and this arrow is pointed up. So since this loop is going down, and this arrow is pointed up, it's going to be opposite direction, positive sign. So plus 0.3 I1. Going to this battery, I'm going from looking at the loop, I'm going from the positive end to the negative end. So it's going to be minus 15. Then it's going to be minus 4 I2 plus 4 I1. Yep, because this line is going in the same direction as the loop, and then this line is going in the opposite direction of this loop over here. And then I'm going to have the minus 12, because the loop is going from positive to negative. I'm going to have the 6 ohm resistor, so it's going to be minus 6 I2, because current 2 is going through that 6 ohm resistor. And this loop is going down just like that arrow. And then it's going to be minus 2 I2 plus 2 I3, because the red arrow is going in the same direction as loop 2, and this red arrow is going in the opposite direction of loop 3. That's why it's minus 2I2 and then plus 2I3. And then that's it for that one. So that's going to be equal 0. I'm doing the same thing. 0.3 plus 4 will give me 4.3 for I1, positive 4.3. Now for I2, negative 0.3 minus 15. Let me get my calculator out. So it's going to be minus 0.3 minus 15. Oops, sorry, not minus 15. It's going to be negative 0.3 minus 4 minus 6. And then minus 2. And that's going to give me negative 12.3. And then there's only one resistor or there's only one I3, so it's going to be plus 2I3. Sorry, this is a 2. And then for my battery, it's going to be negative 15. So then for the battery, it's going to be negative 15 minus 12. That's going to give me 27, but then it's going to be plus 27 when I move it to the other side of the equation. Because I did minus 15, minus 12, then move to the other side of the equation. And if you ever get confused, you can always check. The loop is going from positive to minus, and then from positive to minus. So this is negative and this is negative. Now loop 3. Now for loop 3, and you can start anywhere in the circuit. You don't have to start a specific location. So I'm just going to start at the 5-volt battery and this 4-ohm resistor. So for that 0.4 ohm resistor, this current, the blue line is going in the same direction as the loop, because the loop is going to be flowing like this, and it's going to be going in the same direction. So it's going to be minus 0.4 I3. And then for this battery, the loop is flowing from the positive end to the negative end. So it's going to be minus 5. Then it's going to be minus 7 I3, because the loop and the current are flowing in the same direction. The loop and the current. And then I'm going to be working on this up here. Now, for this 0.1 resistor, it's getting two currents. So it's going to be minus 0.1 I3. And it's going to be plus 0.1 I1. Because if I look, the blue line is going in the same direction as the current. And this green line, this blue line is going in the opposite direction of the loop for 1. Let's move on to this 5 ohm, so it's going to be minus 5 I3 plus 5 I1. And then moving on to this 2 ohm is going to be minus 2 I3. You probably see a pattern going on, but be very careful, because sometimes it's not always going to be this nice. Like if this loop was in the opposite direction, they will both be minus. Plus 2 I2 equals 0. So adding all my like terms together, I have a negative 0.4 minus 7 minus 0.1 minus 5 minus 2. That gives me negative 14.5. Oops, sorry, I wrote that in the wrong spot. I wrote it in the odd one spot. So it's negative 14.5 for I3. And then for I1, it's going to be 5.1. So plus 5.1. And then for this red, it's going to just be that plus 2. And then for the voltages, I have a negative 5. And then, did I forget my battery? I forgot to add a plus 6. So plus 6 from that battery. So I'm just going to put it at the end. Plus 6 from this battery. I never added it in. So negative 5 plus 6, which is 1. When I move that to the other side, it's going to be negative 1. Sorry about that, guys. So putting all this into my calculator, and I have another video to show you how to put it in the calculator. It's going to be, second, I want to click matrix, and I want to edit my 3x4 matrix because it's 3 rows, and it's 1, 2, 3, 4 columns. If I want to change the dimensions of this matrix, I can just change those 2 numbers. So I'm going to put my numbers in, and I have negative 15.65, enter, 4.3, enter, 5.1, enter, and negative 18. And then I'm going to have 4.3, negative 12.3, 2, and 27. And then I'm going to have 5.1, 2, negative 14.5, then negative 1. Then I'm going to exit out. Then I'm going to go to second, click matrix again, then move over to math, and then go all the way down to RREF. Then I'm going to click the matrix that I want. And it's going to give me these numbers. Now let me check to make sure I did this correctly. Yep. 3, 5.1, 18, 4.3, 12.3, 2, so then I have 5.1, 2, negative 14.5, negative 1. So my answers are this last column, 0.61 for I1, positive 0.61, then negative 1.98 for I2, and then it's going to be 0.01 for I3. All right. And that's how you do a 3-loop matrix.